This is the PostgreSQL application database overview and security hardening presentation by me. Today's topic. The presentation will cover PostgreSQL as a robust database software, everything that it can accomplish, and why it is important to harden the same. The presentation will introduce PostgreSQL before going into the area of how to secure the same from any kind of access and how to maintain the integrity of the data. Introduction to PostgreSQL. PostgreSQL is an open source and free object relational database management system that is famous for being highly flexible, high performance, and SQL standard compliant. It is widely used to manage data in different applications due to the strength and extensibility. PostgreSQL is different from the other relational databases in that it offers support for advanced data types and functionality, and thus it is highly flexible for complex applications. Some of its main functionalities are the support for ACID compliance that ensures the data consistency and integrity and multi-version concurrency control MVCC for effective handling of concurrent transaction. PostgreSQL offers support for stored procedures, complex queries, and foreign keys that make it the first choice of different industries for data management. Why PostgreSQL? PostgreSQL is highly acclaimed for several advantages that include the fact that the software can be modified and redistributed by the developer at will. It is highly scalable and can withstand heavy loads very well, and therefore suitable for small-scale applications and massive-scale enterprise applications. PostgreSQL also allows concurrency, and several concurrent users are allowed to read and write in parallel without any loss of performance. Support for rich data types in the system and the extension community such as PostGIS for geospatial data and full text search for querying large databases also make the system highly popular. PostgreSQL also supports being cross-platform and performs well on Linux, Windows, and Mac OS, and therefore the system can be installed on different systems based on the requirement. PostgreSQL has specific application in applications where there's a high need for integrity in the data, for instance, in the case of finance, geospatial applications, and data analysis. PostgreSQL boasts, PostgreSQL architecture. PostgreSQL boasts clean separation between components that work in conjunction with one another for processing queries and handling the data. All the data in the database gets stored in the form of tables and gets processed by the queries. PostgreSQL adheres to server-client approach where the PostgreSQL server executes all the requests made by the clients and the clients communicate with the database using APIs, command line utility, or graphical front ends. Storage layer performs the physical file system on the disk, and the system may also be configured using the use of table spaces for the physical organization of data. PostgreSQL also makes use of multiple processes. The postmaster, that's the main process executing the client connections, and several back-end processes that execute individual queries. Isolation between the components makes PostgreSQL very scalable and manageable. Importance of database hardening. Hardening the database means protecting the database from being vulnerable and minimizing the footprint of the attack. PostgreSQL needs hardening in order to prevent sensitive information from going into the hands of unauthorized persons, data breach, and also meet their regulatory and security needs. Hardening prevents exploitation by known exploits like SQL attack, privilege escalation, and denial of service attack. PostgreSQL, being one among the most popular databases in all the sectors, makes one among the favorite targets for the attacker, and careful application of the steps for hardening is needed in order to maintain the secrecy, integrity, and availability of the information in the database. In addition to preventing any access by any unauthenticated user, PostgreSQL hardening authenticates the authenticity of the system to the user. PostgreSQL security risks. Despite having a good reputation in terms of security for PostgreSQL, there are also potential threats that need to be alleviated. They include common weaknesses such as poor user access methods, unencryption of the data, and misconfiguration of roles and permissions. Misconfigurations within the database system provide access by the attackers through SQL injection attacks, escalation of privileges, and access to sensitive information. Data encryption or repository encryption deficiency may lead to leaks or interceptions. Misconfigurations within the access controls and the assignment of the privileges are also another factor for threats because they provide the user access above the requirements for the function of the user. There are also certain PostgreSQL extension specific threats such as PostGIS or custom modules that are vulnerable if poorly configured. This is hardening recommendation 1, enforcing strong authentication. One of the first things that you must do to harden PostgreSQL is configure strong authentication processes. By turning on SSL/TLS encryption, all traffic between the clients and the service will be encrypted and cannot possibly be sniffed in transit. Strong passwords are also needed. Keeping passwords long and complex reduces the opportunity for guessing or brute force passwords. Multi-factor authentication, MFA, may also be enabled for administrators as the second level of protection. Passwords are stored by PostgreSQL using strong password hash processes like SCRAM SHA-256 that must be enabled in the stead of out-of-date processes like MD5. You must also set up the pghba.configure file so that access to data to the databases may only be accessed from trusted hosts and require strong authentication processes. Hardening recommendation 2, principle of least privilege. Applying the principle of least privilege also forms another critical component towards the PostgreSQL security. The principle ensures that each user and application has the minimum rights that enable the function role. Enable the function. Role-based access control must also be applied in order to grant certain rights for the user based on the user work function. For example, the user performing the work of data entry should not have the permission to delete or modify critical system information. Dividing the sensitive information using schema and table spaces also helps provide another layer of access controls. PostgreSQL also provides fine-grained permission control where the administrators have the ability to provide individual roles towards the database objects such as the table, views, or schema. In addition, revoking the implicit rights from the public role also helps protect the database from being accessed by any untrusted user. Hardening recommendation 3. Enabling logging and auditing. It is critical that logging and auditing are enabled so that abnormal activity can be found and traced. There are several logging options in PostgreSQL that are able to trace any query that is executed against the database. You are able to set the log statement parameter in order that all queries or potentially harmful ones that include deletes and updates are caught. PostgreSQL is also able to trace the client connections and disconnections by using the log connections and log disconnections parameters. Auditing software like PG Audit can be implemented in order that the activity on the statement level is traced in detail, i.e., who did what against the database. These logs must be examined regularly in order that any unauthorized access or malicious activity are picked up by bringing these logs into a SIEM system. Automated detection and reaction against threats are possible. The conclusion. In summary, PostgreSQL itself is strong and capable database software. Though the need for protection of sensitive information necessitates it, PostgreSQL database administrators will reduce the threat of security breaches by using strong authentication controls, the concept of the least privileged access, and logging and auditing in great detail. Installation monitoring, patching known weaknesses, and auditing access controls on regular basis are essential in maintaining the safe environment. All these provide strong foundations for database hardening for protection and long-term resistance against potential breaches. Your consideration and any questions you may have are appreciated. This is the end of the presentation.